All right, we're going to look at the second part of compound event predictions. Grab yourself a piece of scratch paper so that when it's your turn to do some work, you'll be able to get that done. All right, so these are going to look at some examples of using compound probability in simulations to make some predictions. It says at a street corner, a vehicle is classified either as a car or truck, and it can turn left, right, or go straight. About an equal number of cars and trucks go through the intersection and turn in each direction. Use a simulation to find the experimental probability that the next vehicle will be a car that turns right. Okay, so what we have to do is set up some kind of model. So step one is we're going to choose a model. We're going to use a coin, and we're going to use a coin toss to model the two vehicle types. We're going to let heads equal car and tails equal a truck. So there are two possible outcomes there, car or a truck. Then you have a spinner right here, and it's been divided into 3 equal sectors to represent the 3 directions as shown. Left is red, right is blue, and straight is yellow. Step 2, so we have our 2 models. We have the coin and we have the spinner. Find the sample space for the compound event. There are 6 possible outcomes. So if you have a car, the car can go left, the car can go right, the car can go straight, the truck can go left, the truck can go right, the truck can go straight. So what you would end up would be, the possible outcomes would be this. You could have car left, car right, car straight, truck left, truck right, truck straight. You have 6 possible outcomes. So we're going to take that information and we've set it up into a table. Now, if we have flipped that coin, says a coin was tossed and a spinner spun 50 times. The results are shown in the table. So you have a car turned left 8 times, a car turned right 6 times, a car went straight 9 times, truck turned left 9 times, truck turned right 11 times, and a truck went straight 7 times. So it says find the experimental probability that a car turns right. So first of all, you need to make sure that you know that we have spun and flipped that coin 50 times. That's the total number of trials. We are looking for car turns right. So according to our table, that car turned right 6 times, and we spun it 50 times. So the probability would be 6 out of 50. Here's our 6 and 50 up here. Now we know that 6 and 50 are both even numbers. So take a minute and simplify 6 50s and see what you get. If you remember that 6 and 50 are even numbers, they both can be divided by 2. So 6 divided by 2 and 50 divided by 2 is going to give you 3/25. So based on the simulation, the experimental probability is 3/25 that the next vehicle will be a car that turns right. All right, we're going to look at another sample problem. Again, you have a table. Also in the sample problem, it tells you how many times the big number, the total number. So a dentist has 400 male and female patients that range in age from 10 years old to 50 years old and up as shown in the table. What is the experimental probability that the next patient will be female in the age range of 22 to 39? So we're looking for the probability of female patient age range 22 to 39. Total number of female patients in that category is 50. Total number of patients was given up in the example problem, which is 400. So our ratio would be 50 to 400. Now, again, I want you to simplify this. Remember that 50 and 40, you could take out one of those zeros and end up with 5 over 40. Then you would divide 5 into 40. What do they have in common? What factor do they have in common? Take a minute to simplify. You should have gotten 1/8. 50 divided into 400 will go 8 times. If you have any questions, please make sure you reach out to your teacher, and hopefully you can get that. All right, have a great day.